Hello friends, I am your friend Takshil Yadav. Welcome to my channel Takshil Yadav. This is the part 4 of the class 8 mathematics first chapter, that is rational numbers. Till now in the part 1, part 2 and part 3 we have discussed the 4 types of numbers, the closure property and the commutative property. In this lecture we are going to discuss the associative property. We are going to discuss the associative property of the 4 types of numbers with the 4 operations. Let's start. We will first start with the first type, that is whole numbers, and the operation as addition. In addition, the method for whole numbers to find whether the whole numbers are associative in the case of addition is a plus b plus c. Here we put a bracket, in this case over here should be equal to what? It should be equal to a plus b plus c. Here we put bracket on the RHS on the first 2 numbers, and in the LHS we put the bracket on the last 2 numbers. We'll check it by taking values. Great. Let's start. I'll take the value of A as 3 and the value of B as 5 and the value of C as 7. 3 plus 5 plus 7. Here 5 plus 7 are in bracket, so I'll solve them first as per the BODMAS rule. 5 plus 7 is 12 and 12 plus 3. 12 plus 3 is 15. So answer on LHS is 15. Let's solve the RHS. On the RHS we put the values, that is, here we put the bracket 3 plus 5 plus 7 and the bracket on first 2. 3 plus 5 is equal to 8 and 8 plus 7. 8 plus 7 is equal to 15. 15 and 15 both are equal, verified. Thus we can say that whole numbers are associative in the case of addition. Whole numbers are associative in the case of addition. Here I'll put a tick for yes. Now comes the second operation, that is subtraction. In the case of subtraction, the method used to verify whether whole numbers are associative or not is a minus b minus c should be equal to a minus b minus c, right? Let's put the values, okay? I'll take the same values as in the addition. Well, the values were 3 minus 5 minus 7 here, and on the RHS we have 3 minus 5 bracket minus 7. Here 5 minus 7. 5 minus 7 is equal to what? 5 minus 7 is equal to minus 2. And minus 2 minus 3 minus minus 2. And here we have minus 2 minus 7. Minus and minus when together multiplied, because there is a bracket, and when we have to open the bracket we multiply the signs. So we have 3 plus 2, that is equal to minus 2 minus 7. Here the signs are same, so the numbers will get added and the sign will be negative. 3 plus 2 is equal to 5, and here we have minus 9. Is minus 9 equal to 5? No way! So not equal. Hence we conclude that whole numbers are not associative in the case of subtraction. So cross. Let's move further. Now what is the third operation? You can see on the board. It's a multiply sign. And what does a multiply sign stand for? The multiply sign stands for the multiplication operation. You understand it very well. So let's look at the method. The method is that a into b into c should be equal to a into b into c, okay? And here we put the values. 3 into 5 into 2, I say, and 3 into 5 into 2. 5 into 2 is 10 and 10 into 3 is 30. Answer 30 on the LHS, and on the RHS we have 3 into 5 15 and 15 into 2 30. LHS RHS equal. Hence or therefore we conclude that whole numbers are associative in the case of multiplications. Tick. Now comes the last operation, that is division. In the case of division, the formula that should be used is, or the method that should be used is A divided by B divided by C should be equal to A divided by B divided by C. I take the values here, 3 divided by B into C. I take the values of B and C same. B and C as 9 divided by 3. Okay? And 9 divided by 3 is 3, and when 3 is divided by itself, the answer comes out is 1. The answer that comes out is 1. On the LHS. What about the RHS? We just forgot about it. Well, on the RHS we have A divided by B divided by C. Here we have 3 divided by 9 divided by 3. Okay? So 3 divided by 9 is 1 by 3, which when divided by 3. So we multiply 1 by 3 by the reciprocal of 3, because when we divide two numbers or two fractions, we actually multiply the dividend. We actually multiply this dividend by the reciprocal of the first number or the divisor. So we have 1 by 3 into 1 by 3, that is equal to 1 by 9. On the RHS, are 1 and 1 by 9 equal? No. Hence, we conclude that whole numbers are not associative in the case of division. Cross. We have answer as no. Let's move further to the second type of numbers. The second type of numbers are integers. What are integers? Integers are the numbers. All the negative numbers, 0 and the positive numbers together form the integers. Now we'll check the associativity of integers with the addition operation. Here we have the formula as the same as whole numbers. The formula is A plus B plus C should be equal to A plus B plus C. Okay, that's right method. Then we go with the values. I put the values here and I take them as 4 plus 3 plus 2. Right. And here I again put the values. A is 4 plus 3 plus 2. 3 plus 2 is 5, 5 plus 4 is 9. We all know that. And on the RHS we have 4 plus 3 7 and 7 plus 2 9. 9 and 9 are equal. Hence integers are associative in the case of addition. Right. Next comes the next operation, that is subtraction. In the case of subtraction we have the method as A minus B minus C should be equal to A minus B minus C. Right? We put the values as the same. 4 minus 3 minus 2 should be equal to 4 minus 3 minus 2. Okay, 3 minus 2 is 1 and 4 minus 1 is 3. 4 minus 3 is 1 on the RHS side, right? 4 minus 3 is 1 and 1 minus 2 is minus 1. 1 minus 2 is minus 1. 3 and minus 1 are not equal. Therefore, integers are not associative in the case of subtraction. Cross. let's move to the next operation. What is the next operation? Well, the next operation is multiplication. The next operation is multiplication, and the method used to find whether integers are associative or not is the same as that of the whole numbers. The method is A into B into C. We can write B into C straight as BC because it means that we are multiplying B by C. And if we even don't put a multiplication sign over here and we just write it as A, B, C, it is also right because here we are actually multiplying all the numbers. And this was on the LHS. On the RHS we have A, B and C, right? I take the values 4 into 3 into 2. Remember, when we are taking variables, or we can say alphabets as a form of unknown numbers of which we can take any value, we do not put the multiply sign, or we can, but usually we don't. But in the case of numbers, we have to put. In the outside the bracket we do not need, but inside the bracket we need to. And on the RHS we have 4 into 3 into 2. 3 into 2 is 6 and 6 into 4 is 24. And 4 into 3 is 12. 12 into 2 is 24. 24 and 24 are equal. Therefore, integers are associative in the case of multiplication. Answer, yes. Now comes the fourth and last operation in the case of integers, that is division. In the case of division, we have the formula as A divided by B divided by C should be equal to A divided by B divided by C. I get the same values. 4 divided by 3 divided by 2 should be equal to 4 divided by 3 divided by 2. Okay? 3 by 2. We have 3 by 2 divided by 4. 4 divided by 3 by 2. As we already know that if we are dividing two fractions or we are dividing two whole numbers or natural numbers, or we are dividing a whole number and a fraction, then we are actually multiplying the dividend by the reciprocal of the divisor. 4 is the dividend, same, multiplied by reciprocal of the divisor, that is 3 by 2, whose reciprocal is 2 by 3. And on the RHS we have 4 divided by 3 divided by 2. We give 4 by 3 as same and multiply it by 1 by 2. 2 to 2 cancel, and here we have 8 divided by 3 as answer. But on the RHS we have the answer as 2 by 3. 8 by 3 and 2 by 3 are not equal. Therefore, we can conclude that integers are not associative in the case of division. So, the answer is no. Let's move further to the third type of numbers. Well, these numbers are rational numbers. In the case of rational numbers, we already know that rational numbers are the numbers which can be expressed in the form of p by q, where q is strictly not equal to 0. So, the method to find whether rational numbers are associative for addition or not are a by b plus a by b plus c by d plus e by f should be equal to A by B plus C by D plus E by F. I take the values of A by B, C by D and E by F. A by D as 4 by 2 plus C by D as 6 by 2 and E by F as 9 by 3 is equal to 4 by 2 plus 6 by 2 plus 9 by 3. 4 by 2 plus 6 by 2 plus 9 by 3. Here we have 2 and 3. We'll solve them. Actually, we can cancel these rational numbers. 2 and 6 can be cancelled up to 3 and 3. So we have 3 plus 3 in the bracket and outside we have 2 cancelled. 2 plus 3 plus 3, that is 6 plus 2, 8. 8 will be the answer on our LHS. On the RHS, we have on the RHS, I am doing here 8 is equal to 12. 4 by 2 plus 6 by 2, 2 and 3. 2 plus 3 is equal to 5 and 5 plus 3 cancelled. 5 plus 3 is equal to 8. 8 and 8 both are equal. Hence, verified that rational numbers are associative in the case of addition. Right. Now comes the second operation. The second operation is subtraction. In the case of subtraction, we just change the sign as in the case of whole numbers and integers. The method is A divided by B, A by B minus C by D minus E by F should be equal to A by B minus C by D minus E by F, right? A by B, we take the value again, 4 by 2 minus C by D as 6 by 2 and E by F as 9 by 3 is equal to 4 by 2 minus 6 by 2 minus 9 by 3. 4 by 2 is 2 minus 6 by 2 is 3 minus 3 is equal to 2 minus 3 minus 3. 2 minus 3 minus 3, that is 0. 2 minus 0 will be equal to 2, whereas on the RHS we have this. 2 was the answer on the LHS. On the RHS we have 2 minus 3, that is minus 1, and minus 1 minus 3 will be equal to minus 4. Are 2 and minus 4 equal? No. Unequal. Thus, rational numbers are not associative in the case of subtraction. No. Then comes the third operation. The third operation is multiplication. In the case of multiplication, we have A by B into C by D into E by F should be equal to A by B into C by D into E by F. Well, we have 4 by 2, 6 by 2 into 9 by 3 equal to 4 by 2 into 6 by 2 into 9 by 3. Here we can cancel directly. 3 into 2 and 2 to 2 cancel. We have answer as 9 into 4 into 2. 4 into 2 into 9. And on the RHS we have 2 to 3 and 2 to 2. 3 into 2, 6. Yes, we have 6 into 9 by 3. 3 to cancel and 2 into 9 is equal to 18. And 9 4 is 36. We can cancel 2 and 4, that will be 2. And 9 into 2 is equal to 18. Thus, we have verified, we have proved that rational numbers are associative in the case of multiplication. Answer, yes. Let's move further to the fourth operation. The fourth operation is division. In the case of division, we have the method as A by B divided by C by D divided by E by F is equal to A by B divided by C by D divided by E by F, right? A by B 4 by 2 divided by C by D divided by E by F, that is 6 by 2 divided by 9 by 3 is equal to 4 by 2 divided by 6 by 2 is equal divided by 9 by 3. We can cancel them. 2, 2, 2, 3 and 3, right? So we have 2 divided by 3 divided by 3 is equal to 4 by 2, that is cancelled, 2 and 3 and 3. We have 2 divided by 3 divided by 3. 3 divided by 3 is 1 and 2 divided by 1. Here we have 2 divided by 3, that is 2 by 3 divided by 3, that can be written as 2 by 3 into 1 by 3, and we have here as 2, and 2 is equal to 2 divided by 9. 2 and 2 by 9 are not equal, hence rational numbers are not associative in the case of division. Answer, no. And as we already know that natural numbers have the same properties in the case of all the 4 operations as those of whole numbers. So natural numbers are associative in the case of addition and multiplication, but they are not in the case of subtraction and division. Here another time we have got to see that in subtraction and division, just like the commutative property, we have again to see, or we have found out that any of the 4 type of numbers is not associative in the case of subtraction and division, and they are associative in the case of addition and multiplication. So thank you friends for watching this video. I hope you got something new to learn from this video. If you want to keep watching more videos on many topics of different types, interesting topics, please subscribe my YouTube channel Takshil Yadav for more videos.